A project manager recently approached me with a task that we needed to do within a GIS, and that was to create sample points per this systematic random incremental methodology sampling pattern. The trick here is to establish random points on a cell by cell basis within a decision unit. This one is denoted as decision unit 1. We needed those random sample points to have the same relative position from cell to cell within a decision unit. But we also needed random sample points placed in all of the other decision units as well. 2, 3, 4, 5, and so forth. The challenge was establishing those random samples to be the same placement relative to each other within the decision unit, but to have spatial placement that was different between decision units. To do this manually, aside from being very labor intensive, there's really no way to consistently do it. So I developed a Python tool to do this. There is no already prepackaged out-of-the-box tool within the ESRI ARC toolbox that will do this for you. It must be scripted. This tool can be easily run and rerun over and over again very quickly. The user calls up the tool and then selects a workspace and a decision unit grid. Each cell within a decision unit has a decision unit designation. It also has the size of the cell, in this case 100 by 100 feet for decision unit 1, 50 by 50 feet for decision unit 3. There are many cells within a decision unit. So again, the tool that I've written to do this really only has 2 input parameters. It's got a workspace that needs to be declared, and then the decision unit grid, which is the colored cells in the back. The tool can then be run, and in 20 seconds the tool has added about 1,200 random points spread amongst 10 separate feature classes. And we can see after adding the 10 feature classes that the cells that are placed within the decision unit, they're randomly placed, but their position is the same relative to each other between the decision unit. You can see that the same thing has been done for decision unit 3, decision unit 2, and so forth. In the event that project team doesn't really like the randomness pattern chosen, this can easily be changed. So keep an eye on decision unit 3. I'm going to run the tool again. Okay, again, note the time and elapsed time that's passed. Again, 20 seconds. And here's decision units 3 points. Yeah. So, really helpful tool, very quick, and really useful for this incremental sampling methodology. Information on the actual sampling method can be found here, but I thought this was a really good example of how we can use Python to really expedite the production of something that would otherwise take a really long time. Another really nice feature about this script is that it's been preloaded with field values that will allow the user to symbolize based on the original sample, the purple dot, the duplicate sample, the pink triangle, or the triplicate sample, which is the mauve looking square right here. Okay, thank you.